This is section 3.5, Interpreting Graphs. Recall, we can find a function value by substituting a number or variable into our equation and simplifying. We can also find a function value by looking at the graph of the function. To find a function value, we go to the x-coordinate or input given, and your answer is the y-coordinate at that input. So let's look at finding function values for the two graphs that we have below. The first one asks us to find f of negative 2 for this given function. So here's negative 1, here's negative 2 on my x-axis. So when x is negative 2, I look, well, my y value would be negative 1. Then it asks me to find f of negative 1. Well, f of negative 1 has a y value of 0. F of 0, y value of 1. F of 1 has a y value of 2. F of 2 has a y value of 3. Let's do the same thing with the graph over here. F of negative 3 has a y value of 0. F of negative 2, let's just round to 1 there. These graphs are not perfect. F of 0, call that 3. F of 2, I'm going to call that 3 as well. And f of 3 is 0. So, just like we could find function values by substituting the number or variable in for x, and simplifying or evaluating, we can find a function value given a graph by going to that x-coordinate and finding the corresponding y-coordinate. Recall, we can determine if a relation is a function by seeing if any domain values repeat and have different range values. Recall our example with a $145 ticket being linked to both Oregon and Utah, and that would make it not a function, right? We can determine if a relation is a function by looking at its graph as well. The vertical line test states that if every vertical line crosses the graph of a given relation at most once, then that relation is a function. Okay, so we can use the vertical line test to determine if the graph of a relation is a function. So, the vertical line test again states that if every vertical line crosses the graph of the given relation at most once, then that relation is a function. So let's graph 3 different examples here. Here's one. We can make 2, and then 3. All right, so let's look at the first one. Is this relation that I have graphed a function? If it is a function, then every vertical line that I could draw on this graph will only cross this purple graph once. And if you look, every vertical line that I've made has only crossed it once. So yes, this is a function. Let's look at our second one. Here's the first vertical line that I drew. And the very first time I drew a vertical line on this graph, I crossed my relation in 2 separate places. So this is not a function. Okay? Think of it again just as a computer. At the input value of 1, my output value is either 3 or -2. So my computer wouldn't know if they should be telling me 3 or -2. Okay, next one, again, I fail my vertical line test, so I am not a function. So we can tell if a relation is a function by performing the vertical line test. If that vertical line crosses in more than one place, then we're not a function. Now let's look at finding the domain and the range of a relation given its graph. The domain of a relation is all the x values that relation covers. In order to find the domain, you need to look at the endpoints of the relation that is graphed. Since domain deals with the x values and the x-axis is horizontal, we will look left to right to find these values. The range of a relation is all the y values that relation covers. In order to find the range, you look at the highest point and the lowest point of the relation that is graphed. Again, because the range deals with the y values and the y-axis is vertical, then we look from the lowest point or bottom to the highest point or the top. So we're going to be finding domain and ranges of relations. Domain will look left to right. Range will look bottom to top. We will write the domain and range that we find using interval notation. Recall, interval notation represents a set of numbers. It contains either a bracket or a parentheses, and then the smallest number that we have in that interval, a comma, the largest number that we have in that interval, and then we end our interval notation with, again, either a bracket or a parentheses. For those of you who may have forgotten, recall that infinity and negative infinity always use parentheses. Remember, parentheses means that you cannot include that number, so you have an open circle. And brackets means you can include the number, so you have a closed circle. So let's find the domain and range of all the rest of these functions. That's the rest that we have in this section. So let's look at the first one. I need to find the domain and the range of this function. Well, I'm going to do this, and I encourage you to do this on all your papers until you feel comfortable with finding domain and range given a graph. I'm going to extend the arrows. And the reason that I extend the arrows is that it's just going to help us as we find that domain and range. Now, domain, again, is all the x values. Well, here's my x-axis. This is my x-axis. So I need to figure out, okay, which values can I actually be on this x-axis? And our arrows are going to let us know. Well, the last point is an arrow. So if you notice, I'm going off to the left. If I'm going off to the left on the x-axis, that means I'm headed toward negative infinity. So my domain starts with a parentheses and then negative infinity. That is where I'm heading. That is my leftmost value. Then I notice that I don't have any holes or anything or jumps that I need to worry about. And I go to my next thing, and that's a right arrow. Well, that means to keep going up and right this way. So I'm going off towards the right on my x-axis. Well, that tells me that I'm going to positive infinity. So the domain for this relation is negative infinity to positive infinity. Now the range is your y values. Now remember, this is your y-axis, vertical axis here. And for this, we're going to look at lowest to highest. Well, the lowest point that I had was an arrow, right? And that told me I kept going down. Well, if I look here, if I keep going down, then that tells me I'm going towards negative infinity on my y-axis. So I put parentheses, negative infinity, comma. The highest point that I have is this arrow. Again, that tells me I'm going to keep going up. So that means I'm going up on my y-axis. And as I approach up on my y-axis, I head towards positive infinity. So the range for this relation is from negative infinity to positive infinity. Those arrows are telling me that I'm going, since it's down, negative infinity, since it's up, positive infinity. Let's look at our second relation graphed here. Again, I encourage you to just kind of extend your arrows as much as possible until you get more accustomed to working with this. And let's look at domain. So here's my x-axis. All right. Now, leftmost point was an arrow, which means I'm going off this way. If I'm going off towards the left on my x-axis, I am headed towards negative infinity. So I start with negative infinity. There are no breaks or jumps in my graph, and I head off to an arrow, and this arrow is going towards the right. So I'm going this way, so I'm going more and more right on my x-axis, which means I'm headed towards positive infinity. So the domain of this relation is negative infinity to positive infinity. Now let's look at the range. Again, the range is all your y values. So the lowest point on this graph is right here. That is the lowest that I go. And that lowest point is at y equal negative 1. It's at negative 1 on my y-axis. Can I be negative 1? Yes. How do I know that? Well, if I take a look here, I don't have an open circle at negative 1. I have a closed line. So negative 1 is included in my range. So my range is going to be from bracket, and again I use a bracket because it's included, negative 1, comma, and then I need to look at my highest point. The highest point here are arrows, which means I'm just going to keep going up, and I'm just going to keep going up. Well, if I keep going up on my y-axis, I am headed towards positive infinity. So my range is from negative 1 to positive infinity. Next one, let's look at the domain and range of this function. Again, until you're more accustomed to it, I would just continue to extend these arrows, kind of help us out. Here's my x-axis. So I got an arrow on the left and an arrow on the right. At this point, I think we realize that an arrow, as long as it's still kind of pointed in one direction on the left and right, is telling me that my domain is going to go from negative infinity to positive infinity. This is also because I have no breaks or jumps within the graph. We'll get to breaks and jumps in the next page. Let's look at my range. The range here is a little tricky. Recall, your range is your y values. So I have to look at my lowest point, my highest point. That's why it's a good idea to extend your arrows. You might have been tempted to say that this was your lowest point. But if you look here, don't these arrows extend way further than that point? They do. Okay, these arrows tell me that I'm going towards negative infinity on my y-axis. So my lowest point is negative infinity. Then I look for my highest point. Well, if I look on this graph, this is my highest point. That is the highest that I go. Well, what is that point? Well, if I look here, that should be 1, 2, 3, 4. Can I be 4 on my y-axis? Yes, I can, because it's a solid line. So I'm going from negative infinity to 4, and I use a bracket, again, because 4 is included. Okay. This was what I was talking about, jumps and breaks. Let's look at our next picture. Our next picture, again, let's look at the domain. Domain is my x's. Notice I can't extend anything here. The reason I can't extend is I have no arrows. If I don't have arrows, I can't extend these things because it's not allowed. That arrow tells me to extend. If it's a solid circle or open circle, I cannot extend my graph. So let's look at my x values. What is the leftmost point that I have? Well, negative 1, negative 2, negative 3. It's right here at negative 3. So my domain starts at negative 3. Again, I use a bracket because I have a closed circle. It's included. Then I go along. I don't have any jumps or breaks. And then I get to here. That is my last point. And that's at 1, 2, 3, 4. Positive 4. But I need to use a parentheses with positive 4 because it's not included. It's an open circle. The domain for the given relation here is from negative 3 to positive 4. Let's look at the range. Again, the range can sometimes be tricky because you need to look at the y value, and a lot of people are tempted to only look at the x value. What's the lowest point? Well, the lowest point that I have on my graph is this. Well, what is the y value of that point? The y value of that point is 0, and I can be that 0 because of my closed circle. So my lowest point is 0. Well, what's my highest point? It's not this. This isn't my highest point. Notice, I'm way higher than this up here. Well, if I look here, my highest point is at 1, 2, 3, 4. 4 on my y-axis. And I can be that 4 because I have my closed or solid line. So my range is from 0 to positive 4. And again, I use a bracket because it's a solid line. Okay, the next graph that I have, let's look at the domain and range of this graph. Domain. I'm going to extend here because I can, because I have arrows. My leftmost point here is an arrow. Okay, again, my leftmost point's an arrow. What does that mean for me in terms of domain? It means I'm headed toward negative infinity. Then I go along and I notice I have a jump. My issue was x equal 1. Can I be x equal 1? Well, yeah, I can't be that y value, but when x is 1, y is 2, it looks like. So I'm allowed to be that x value. So I have fixed my jump here for my x-axis, or my domain values. Then I keep going on, and I have an arrow that gives me this way. Well, it means I'm going to the right in my x-axis, which leads me to positive infinity. Let's look at the range for this. And I'm going to just remove all this information and redraw it so you can see the range. Again, for the range, we're looking at the y. Go ahead and extend these out again. Now recall, with my range, I'm looking from my lowest point to my highest point. Well, my lowest point is an arrow. If my lowest point is an arrow, then I know that I'm going down to negative infinity on my y. So I negative infinity. Comma. As I go along, I'm fine until I get this y value of 1. I have an open circle. Well, I need to look and see, can I be y equal 1? Did I ever fix that problem? I didn't. So I have to stop at 1 and put a parentheses. I cannot be 1. I'm not allowed. I never fixed my issue like I did here for x equal 1. I fixed the issue. I have an open or a closed circle above it, but I never fixed it for y equal 1. Then I'm going to union. Now, I'm going to erase this off and look at it again. If we take a look at this, am I allowed to be any of the numbers this isn't the best graph, so let's pretend that it went a little more higher like this and not so far down. But if you look at this, can I be any of the numbers here between 1 and 2? No. Okay, I know it looks like we were, but ignore that. It's hard to draw graphs on Word. I can't. So what we're saying here is that I can't be any number between 1 and 2. If I can't be the numbers between 1 and 2, then I can't include them in my range. So the next possibility that I have for a number in my range is 2. And I'm going to put a bracket with 2 because if you notice at y equal 2, I have a closed circle. And then I'm going up to an arrow, which means I'm headed to positive infinity. So the range for this graph is from negative infinity to positive 1, parentheses, a union, because I'm jumping up, to 2, all the way to positive infinity. All right, let's look at the domain and range of the next one. Again, I'm just going to go ahead and extend those on. The domain, or the x values, well, arrow, my domain tells me I'm going to negative infinity all the way up. I have a hole. Did I fix it? Yes, I did. So I can keep going up, right arrow, positive infinity. Let's look at that range. Range, recall, is your y values. Lowest point is an arrow, tells me negative infinity. Okay, I'm fine until I get to y equals 0. Did I fix y equals 0? No, I'm never allowed to be 0 on my y-axis. So I have to stop at 0 and put a parentheses. Well, I can be any number bigger than 0, but I have a hole here at 0. I'm not allowed to be 0. Again, if we look at this without all this drawn on the graph, notice the only number that I can't be is 0. So how do I write this? Well, I union, because remember, whenever you have a jump that you don't fix, because again, I did not fix the fact that I couldn't be 0 on my y-axis. I start back up at 0. Again, I need a parentheses because I'm not allowed to be 0. And then I go all the way to positive infinity. So the range here is negative infinity to 0, union 0 to positive infinity. All right, let's look at the last 3 here. Let's look at the domain of this. And I'm going to extend these off. Okay, well, my domain, left arrow, correct? Negative infinity. I have an issue that got fixed. Right arrow, positive infinity. My range. What is my lowest number? Notice this is just a horizontal arrow that's going off. Hey, this isn't pointed down. Notice I didn't angle the yellow highlighter down. I'm just going off horizontally to the left at y equal negative 3. So my lowest point here is negative 3. Now I'm not allowed any negative 3 here at x equals 0, but at x equal negative 1, or at x equal negative 2, or at x equal negative 3, or keep going, I'm always allowed to be negative 3. So my lowest point is negative 3, and I can start it with a bracket. Then from here, again, let me erase this so we can have a better picture. So from here at negative 3, then I jump all the way to negative 1. So I'm not allowed to be any number between negative 3 and negative 1. So I'm going to close negative 3 off because I can be negative 3, but then I have to union it all the way to my jump, which is negative 1. The reason I put negative 1 in a bracket is because of that closed circle. Now recall, yes, there's an open circle here, but it gets fixed. My open circle gets fixed with that solid line over there to the left, which is why negative 3 is in brackets. Highest point is an arrow, which means I'm going to infinity. So the range here is negative 3 union negative 1 to infinity. All right, let's go ahead and look at the domain and range of the next one. Okay, my domain. I have an arrow and an arrow. So you might just be tempted to write negative infinity to positive infinity, but remember there's a hole. Did I fix the hole? This is the very first time that I have not fixed a hole for my domain. Okay, nope. I am never allowed to be 0 on my x-axis. Never. I don't exist on this relation at 0. Okay, so that means leftmost point, negative infinity. I have a hole at 0, so I have to stop there with a parentheses, again parentheses because I have an open circle at 0. I union it, I start right back up at 0, and I go arrow to positive infinity. So because I'm not allowed to be 0, my domain there is negative infinity to 0, union 0 to infinity. Let's look at my range. Range is your lowest point to your highest point. Well, if we look here, the lowest point that we have is right here at negative 1. But can I be negative 1? No. Why can't I be negative 1? Because on my y-axis there I have an open circle. So my range, I have parentheses, negative 1, comma, well what's my highest value? Well, my highest value is a bunch of arrows, which means I'm going up on my y-axis, which means I'm going to positive infinity. So I'm going from negative 1 to positive infinity. Last one, domain here. Okay, I look at those arrows. So that tells me, going off to the left and going off to the right, I have a hole. Did I fix my hole for my x? Yes, notice every time I'm trying to see if I fixed a hole for the x values, I make a vertical line. And every time I try to figure out if I fixed the hole for my y value or my range, I make a horizontal line. So I fixed this, so that means I go from negative infinity. I'm allowed to be x equal 1 and to positive infinity. So negative infinity to positive infinity. Let's look at the range values. Well, the range values for this particular function, lowest point is down there. It's at negative 1. I'm allowed to be negative 1 because I have a big circle there at negative 1. And then I jump all the way up to 2. I can't be any of the numbers between negative 1 and 2 because they're not covered there in my graph. Now, can I be 2? Should I use a parentheses or should I use a bracket? Well, again, there's an open circle here at y equal negative 2, but did I fix that open circle? Yep, because of those horizontal lines all around me. At x equals 0, I'm at 2. At x equal negative 1, I'm at 2. At x equal negative 2, I'm at 2. At x equal 2, 3, I'm at 2. Okay, that solid line fixes it, so I go from negative 1, I union it to 2, and that's the only other y value I'm allowed to be. So the range there is from negative 1 union to positive 2. Okay, so in this section, we learned how to find a function value given a graph, how to determine if a relation is a function by performing the vertical line test, and how to find the domain and the range of a relation from its graph.